Sonorous Swifters, it's Prof G, and in this lesson we're going to introduce the toggle view. It acts like an on-off switch, and we'll use it to turn the sound in our app on or off. Now when we do this, we'll get our first look at the important concept of binding in SwiftUI, and while doing this, we'll explore an edge case that could crash your app, and we'll learn how to fix it using compound conditionals. So we'll learn about the double ampersand for and the double bar for or. And if you haven't noticed, our app is also playing multiple sounds one on top of the other. We'll solve that problem too. Conditions are ripe for big learning. Let's code! If you're new here, welcome. You might want to check out the course playlist to see how we got here. So the last time we worked with the You Are Awesome app, we created functions to generate a random value, which we then passed in as part of a sound name to play sounds.
Yay!
And this works great, but sometimes you might want to see your inspirational message and your inspirational image, but you might not want to have that sound play. Not everyone is prepared for your auditory awesomeness. So in order to curtail the dulcet tones of your app, we'll add a toggle so we can turn the sound on or off. And as you see it in this final app, we'll place the toggle to the left of the show message button, and as you can probably tell in here, we've got a spacer between these two elements. Now setting this up is a bit trickier than it looks, but we'll skill you up so you have no setbacks. Now, if I want to place a toggle to the left of my button, I need an HStack before the button. So I'll two-finger click on the word button here, pull up the context menu, and select Embed in HStack. And then after the HStack, I'm going to add my toggle. So to add a toggle view, enter the word toggle. You get a bunch of options in here. Select the one with title key and is on. Notice the code completion says creates a toggle that generates its label from the localized string key. Now the one thing that's curious is that the is on input that we're going to put in here wants a bool, but that's wrapped in something called binding, and we'll describe that in a minute. First press return, and for the title, let's pass in the string as sound on, and for our is on value, we need to create a new state variable. So let's head up to the top of your code, and under the other state values, we'll write at state private var, why don't we call this sound is on, lower camel case, and we'll set this equal to true. Then we can head back down to our toggle, and as we pointed out, this doesn't just say bool, it says binding with bool inside of pointy brackets. Now do this with me now. Let's just enter our new variable sound is on. That's a bool, cool, accept this, but Xcode doesn't like it. We get an error, let's click on the angry error circle, and we see the error is cannot convert value sound is on of type bool to expected type binding bool. Use wrapper instead. It offers a fix button that says it will insert a $sign. So here's what's happening. This toggle is not only updating the value sound is on when we click it, it's also changing the look of the view. See how that switch changes? When it's off, it's at the left in gray. When it's on the right in green. The other views we had, text, image, button, didn't change the look of the view. So when a statement needs to do these two things, update a state variable and update its own view, we say there's a two-way binding. A change is happening inside the view and the state variable is being changed as well. So when we have a variable that's involved in a two-way binding, where the view and the variable is going to be updated, we add a $sign in front of the variable. Now, if two-way bindings aren't entirely clear to you right now, don't worry, we're going to have a whole lesson on them in the future. But for now, know that if you forget that you need a binding, Xcode almost always offers a nice fix suggestion in the error. We'll take Xcode up on the option to fix it, click on that fix button, a $sign shows up out front, error goes away, and the toggle will work, updating both the view when clicked and the state variable. That's what two-way bindings are all about, and again, we'll learn more about them in a future lesson. That's looking good. Our toggle shows up. Now let's add a spacer in between the toggle and the button, and this looks like the spacer isn't doing anything. Let's explore why. First, let's see what happens if we change the label to an empty string. We still see the toggle pushed next to the button, and it looks like there's text in there that's taking up all of the space, even though I have no string in that part of my toggle. Let's add a border around the toggle view to take a look at the space it's taking up on screen. Remember we tried this technique in an earlier lesson? So we'll use the .border modifier below the toggle. I'm going to pass in .blue as my border color. And it looks like the control has the label out to the left even if there's nothing in it. And it pushes the toggle control out to the right. Now we want the label to be right next to the toggle control. Well, one way we can fix this is actually to hide the label and then replace the text that we would normally put in the label by adding a text view in front of the toggle view. So try this. I'm going to introduce you to a new modifier called label is hidden. Under Toggle View, let's type .hidden to access some modifiers that work on hiding aspects of the view. And you should see one in here that says label is hidden, so use the down arrow to select that. And this one says that it hides the labels of any controls contained in the view. It takes no parameters, so press return to add this, and sure enough, our toggle is pushed over to the left, kind of like what we want. We just need to add a text view to the left of the toggle and use that as our label. And so just above our toggle view code, I'm going to add text. And in between parens, pass in the string sound on : and look at that. We got what we want. Now we can delete the blue border on the toggle. Now what we want to do is to take a look at this sound is on value, and if it's false, we want to make sure that we don't play our sound. Right now the toggle works, but when it's off it still plays the sound. Pressing live restarts the app and it'll shut off the sound. So all we need to do for this is to head down into our button action, and down here where we make the call to play sound, before we call that function, we want to wrap it in an if statement that says, if sound is on, remember sound is on is a Boolean value, open curly, so if it's true, and I'll cut out the play sound function and paste it in between the curlies of the if sound is on, so it executes the play sound. But if sound is on is false, that toggle is clicked off, we'll never play the sound. So let's try this out. If I click the toggle off, then click the show message button, I don't hear any sounds. That's great. But if the sound is already playing, clicking the play sound toggle doesn't stop the sound from playing. It would be nice if we could detect if somebody had tapped the toggle, and if the sound was playing, we could stop the sound from continuing to play. Let me show you how we do that. What we want to do is see if someone has tapped the toggle, and if they did, if the sound is playing, then we want to stop the sound from playing. So first, to perform an action when the toggle is pressed, we're going to add a new modifier to the toggle with .onChange. There are a bunch of onChange modifiers in here. Select the one with the of and action properties, and code completion says that this adds a modifier to the view that fires an action when a specific value changes. Press return to accept this, and for the of value, just add sound is on. So this says when that variable sound is on has changed, then I'll tab over to the action parameter and press return to get the trailing closure format that I like so much, and this is a closure that executes whenever the sound is on parameter changes. Now what we want to do in here is that if the audio player is playing, we want to stop playing. And the audio player object has a property and a method that we can use for this. First, inside the onChange closure, write IfAudioPlayer.isPlaying. And notice what code completion says in its description, a Boolean value that indicates whether the player is currently playing audio. Nice, straightforward, we want this. Press return to accept this. Now in between the curlies, how do we stop the audio player from playing if this is true? Well, audio player has a method named stop. So we'll enter audioplayer.stop, no parameters for this, but the code completion says stops the playback and undoes the setup the system requires for playback. Stopping the playback sounds like what we want, so press return and let's try this out. Show message will play a sound, but now using the toggle to set the sound off will stop any sound from currently playing. Stop the sound playing, nice. Solid work, Swifter. More skills. But we do have an issue that could crash our code. And this is what developers call an edge case. An edge case is a set of circumstances that might not normally occur when using your app, but if it does occur, it could cause problems. In our case, it would crash our app. Now this is going to happen if you launch the app, but instead of pressing show message right away, you instead turn the sound off right away. Now watch this. I'll restart the app in the preview, then I'll turn the sound off, and yow! Preview crashed. And if you get an alert like this, you can always click on OK, but we still won't see our app running. Now, when preview crashes gloriously like this with a circle and X in it, we don't get very good error feedback. Now, one way to get better feedback is to run our app in the simulator. Now, the simulator is a separate program that's installed with Xcode, and it simulates an iOS device. So to launch the simulator, first make sure that we have a device selected, and you can do that under the scheme area of Xcode. That's where you choose a device. The scheme is located in the window title bar, just to the right of the name of the app. Click and pull down this menu and select the device that you want to simulate. I'm going to simulate the same device in my preview. Pro tip, if your Mac is slow, selecting a larger device takes more processing power, so the simulator is going to run slower. Then to launch the app in our simulator, we click this play button. The simulator only launches if Xcode detects no errors at launch. We see the hammer message that says build succeeded. When I see that, I like to yell hammer time to celebrate that my app has no errors at runtime. And now the first time you run in the simulator, each time you reopen your Xcode project, it usually takes 30 seconds or more. Subsequent launches will be faster, but be patient the first time. You'll notice some swirling in an indicator in the upper right, and some messages here will change. And then the simulator launches. And this is a separate app. It's not Xcode, but it's connected to Xcode. And again, it takes a second or two before the app starts to run. But here is my app. No errors yet, but let's do the same thing. We'll click the sound on toggle so it's off. Now we see an error occurred at runtime, and we also see in the navigator pane we're no longer in the project navigator. We're now in the debug navigator. The icon with a little can of bug spray is highlighted. We can ignore the info in the debug pane, but let's look at our code. This red line in my code shows the exact spot where my code crashed. Now the red underline in this line of code is Xcode's best guess at what caused the problem, so it's underlining AVAudioPlayer because it seems that's the culprit. Now if we click this little red circle of anger next to the word thread, we see a more complete error description. Xcode says fatal error, unexpectedly found nil when implicitly unwrapping an optional value. And it says the same thing in the console down here. What gives? Well, you might recall that we had to declare but not initialize our audio player. See up top here with our state variables? Because we didn't have access to the assets catalog file, which is what we need to set up the audio player. So to be clear, when the code first starts and it hits this line, the audio player box to hold the data is created. We call that declaring the variable, but it hasn't been initialized. There's nothing in that box or in the variable called audio player. Since it has nothing in it, we refer to that as being nil. That's as opposed to these other values here, which we initialized, we set them equal to something. Now, if we scroll down to our play sound function, I'll hide the navigator's pane so you can see things better. This line of code here with the try in it actually tries to assign data to the audio player. So if we get to this line and the try works, we don't have nil in audio player anymore. Instead, audio player has been set up and it has the data we need to play the sound. No problem. We haven't run into any problem down here before. But the successful setup of the audio player only happens when the show message button is pressed. If we don't first press show message to play a sound, and then instead we just click the toggle button first and turn sound off, this line here looks inside the audio player to try to find the isPlaying property. But since audio player is nil, there is no isPlaying property, and you can't look at a property in Swift if you're expecting a value but instead get nil. If that happens, the code will crash. So how do we fix this? Well, we just want to make sure that the audio player does not equal nil before we go ahead and take a look for the isPlaying property. Now, before we solve this, let me also show you the variables pane. If yours isn't showing, just click the show variables pane icon in the lower right-hand corner of Xcode, and you should see the pane show up on the left. Now, you'll see a little triangle in here that says self, and in parentheses it says you are awesome content view. Now, if I click the triangle to expose what's in this heading, I see an underscore in front of all of the property names that I've created for the content view struct. And if you click the triangles next to each of these items, you see the values of each of these variables exposed underneath. You can ignore the location information, but we see the strings are all empty string. That's what we initialized them to when the app launched. We also see all the numbers are initialized to -1, and audio player, it's nil. That's the reason why our app crashed. So if your app ever crashes, you can explore the variable pane to see what various values were at the point in which your app crashed. This can be really useful, and we will definitely see this more in future lessons. So I verified, yep, my audio player was nil when my app crashed. So now we can hide the variables view pane and hide the debug pane, and I'll click on the stop square in the toolbar. And now let's figure out how we can make sure that we don't try to look at any value inside of an audio player that's nil. Well, there are a few ways to do this. One, which you already know, is we can check to make sure that audio player is not equal to nil. So just before if audio player dot is playing, I can write if audio player exclamation point equals, that means not equal to, nil, lowercase nil, open curly, put the closed curly after the interior ifs curly, and this is what's called a nested if statement. There's an interior if statement that's nested in or inside of an exterior if statement, and the interior if statement will never be reached unless the exterior statement is true. So in our case, it's only reached if it's true that the audio player does not equal nil. Remember, that's what caused our code to crash. So why don't we check this out? Under Preview Crash, I'll click on this circular refresh or reload icon. If you need to, click the Preview's Live Play button in the lower left and click Toggle. No crash. Nice. Does the rest of the app work? Yes, it does. So I'd cheer for you too. But nested if statements are usually something we want to avoid if we can, and that's because they push the code over to the right, and that makes code harder to read. So let me show you another technique, the compound conditional. And to demonstrate the compound conditional, I'll enlist the help of the Grandmaster of Funk, His Royal Badness, the late great purple one, Prince. Now in this sample code, 2 ampersands, that's these squiggly guys here, on the US keyboard you'll find the ampersand above the 7 key. These 2 characters next to each other, no space, act as a conditional and. That means for something to be true, then both what's on the left side and the right side both need to be true. So either side of the double ampersand is either a Boolean expression or a value that returns true or false. So this must be true, and this must be true for the whole statement to be true and for the first set of curlies to be executed. But if either side of the double ampersands is false, or both of them is false, then we skip the first set of curlies, and if there's an else, we'll execute what's in the else clause. Since we're evaluating more than one Boolean condition on a single line, we refer to this as a compound conditional. So, if the person's first name equals Prince, and double ampersand, the last name is the empty string, then we will be greeted with dig if you will my Swift code. Otherwise, we'll print the greeting rock on coder. A silly example, but if we try this out in our playground, we'll see first name Prince, last name empty string, dig if you will my Swift code. But if the person we're greeting has first name Prince and last name Harry, we simply say rock on coder. Nice. But we can get even more complex because, if you didn't know, Prince is actually Prince's real first name, given at birth, but he does have a last name. It's Nelson. Here's his passport photo to prove it. This may be the world's baddest, in a good way, passport photo. I can only aspire to look so cool. So, what we'd like to do is offer up the princely greeting if the person's first name is Prince and the last name is either empty string or Nelson. And to do that, we'll use the conditional or operator. That's 2 bar characters, no space in between them. The bar characters are almost never typed, but on a US keyboard you'll find the bar character as shift \key, which is just above the return key. And if either of these conditions is true, last name is empty string or last name is Nelson, then the whole area between the parens is true. Then this result will be compared using the and double ampersand operator. And if the left side and the right side are true, we will greet them print style. Let's show you this in a playground. So before last name double equals empty string, I'm going to add an open parens. Then after the empty string, I'll type a space, then 2 bar characters. Again, that's shift \, which is above the return key on the US keyboard. Then space, then last name double equals, in quotes, Nelson, and close parenthesis. So this entire expression only evaluates true if the first name is Prince and either the last name is an empty string or the last name is Nelson. Let's shift return with Prince Nelson, dig if you will my Swift code. But with Prince empty string, we also dig if you will the Swift code. But with Prince Harry as the last name, rock on coder. And if we have last name as the empty string, but the first name is Adele, we also greet her with rock on coder. Nice. And if it helps, you can always consult the truth table. With double ampersand, the logical and, the expression is only true if both sides of the ampersand are true, but with the logical or, that's the double bar, an expression is true if either side of the double bar is true or if both sides are true. Now, I also recommend that you use parentheses to group the order of items you want evaluated in any compound conditional with 3 or more expressions. That'll help the reader know which part of an expression is to be evaluated first. So now that we know how to use compound conditionals, let's try this out in our code. So in our nested if statement, I'll cut out the audio.isPlaying. Remember that returns a bool, true or false. And I'll delete the rest of this if line, and I'll delete the ifs close and curly. Control-I to fix the indent. Then after checking if AVAudioPlayer is not equal to nil, I'll add the double ampersand for the and condition and paste in AVAudioPlayer.isPlaying. This looks good. Now let's try it out. Turn that switch off. No crash. Exquisite. Sound works, sound shuts off. Now this is great, but there's one more thing you might notice. Everything works well, but if I play sounds and click the show message button rapidly before the first sound finishes, you'll hear 2 or more sounds play on top of each other. And even worse, if this happens and I toggle a sound from on to off, one sound will turn off, but the other keeps playing. So what we should do to get only one sound playing at a time is we should modify the play sound function to check to see if a sound is playing, and if it is, we should shut it off. So why don't we consider this a quick mini challenge? And here's a big hint. You already wrote code just now to do this. You just need to put that same code in another spot. So why don't you pause, think this through, see if you can solve the challenge, and when you're ready, resume, and let's compare answers. So hopefully you guessed that you need this block of code that checks to see if both an audio player is not nil and if that audio player is playing a sound, and if those are both true, it will turn off the audio player. So with these 3 lines highlighted, I'm going to copy them, then I'm going to head down to my play sound function, and I'm going to paste these 3 lines in as the first lines of code that execute in this function. This should turn off the sound if it needs to, but in either case, the code will continue and play a sound if it can. So let's try this out. Let's rapidly click the show message button. And how about that? So we're now only hearing one sound play at a time. If we click show message again while a sound is playing, that old sound is shut off and the new sound plays. And if we toggle off this sound off and a single sound is playing, it cuts off that sound. Exceptional work, Swifter. I'm cheering for you too. Once again, we had big learning. We learned how to create a toggle view and that interactive views that update themselves and change the state variable require bindings, and that means that we need to include a $sign out front of the variable name. We also used the label hidden modifier. That let us put our toggle right next to a text view so that there was no space in between. We learned about the onChange modifier that executes code if a value has been changed. We learned about the AVAudioPlayer isPlaying property and its stop method. We introduced the concept of the edge case and prevented an edge case from crashing our code. We explored the variables view, or variables pane, in the debug pane. We used nested if statements, and we learned about compound conditionals, the double ampersand logical and the double bar logical or. And we ended with a mini challenge to stop multiple sounds from playing. Skilled one, your app is nearly done. I hope you're feeling good about what we've accomplished. Just a little bit more to go in this app, but there are many more apps ahead. Drop a like or comment to keep me motivated so the goodness keeps coming. Let the hacking continue.